Hello grade 10 students. Today I am here to teach you chapter 26 in your textbook that's called frequency distributions. So this is another statistics unit. Earlier we discussed what is statistics mean. The science of collecting data, organize it and analyzing and take the best possible conclusion is called statistics. Now today we are trying to learn measures of statistics and how we create frequency distributions. So first we'll take with an example and revise what we did before. We did measures like mean, median, mode, range before for raw data set. So we'll just take an example. It's given number of coconuts sold for 7 days by a seller is given below. So these are the days. How many days? 1, 2, 3, 4, 5, 6, 7 days. So they ask what's the lowest number. So when you look at the data set at once we can't find out the lowest. It's difficult. When you arrange the data set in order, it's easy to identify the lowest and the highest. First we'll rearrange the data so that we get lowest to highest. So what's the lowest number there? 100. What's the next number? We get 300. So I can cut it. Then I get 3 500s. 500. 500. Another 500. What else? I can cut these 3. Then I get 600 and 700. So when you look at this data set, at once we can get what's the lowest number. So what's the lowest? 100 coconuts is the lowest number. Highest number? 700. And they are asking what's the range. So what's the range? The difference between the highest and the lowest value is called range. So in this case, what's the range? Highest number minus the lowest number. You get range as 600. So I'll write down what is range. Range is the difference between the highest and the lowest. Now what is mode? Mode is the most frequent number. Most frequent number. How can we identify? When you arrange the data set in order and see most frequent number. In this case, 7 ones, 12 ones, 15 ones, 20 we see twice. So what's the mode there? Mode value is 20. Most frequent number. This is arranged in order, lowest to highest. What's the mode value? 35 we have twice. 45 also we have twice. So in this case you have to write both the numbers. So mode, there are 2 mode values here. You have to write 35 as well as 45. So here when you get one mode value we say unimodal data set. When you get 2 mode values we can say bimodal data set. Now look at the third example. What's the mode? 10 twice, 15 twice and 20 twice. Now you get 3 mode values. So you have to write all 10, 15 and 20. So what is this data set? Trimodal data set. Trimodal data set. So you can get more mode values sometimes. Now take the same example that we took before. Number of coconuts sold for 7 days. We'll try to find out what's the mode number of coconuts sold. So here when you arrange the data set in order, what you get? Again I can write 100, 300, 500 3 times and 600, 700. So this is the data set 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. So what's the mode value? I see 500 3 times. So the mode value, mode number of coconuts sold is 500 in this case. So we know now how to find out the mode value, most frequent number. Median. What is median? Middle of a data set? That's wrong. You have to say when you arrange the data set in order, the mid value we call the median. So this is important. You have to arrange the data set in order. So I'll write down what is the definition of median. Mid value of an ordered set. That means rearrange lowest to highest. Now in this case already ordered. So how can we find out the mid value? So what we can do, we can cross it out from corners and see what's the middle number. So that's also possible if you get very low number of data sets. Now we'll do that way, cross it out and you get 25 as the mid number. So the median is 25. What's the other way you can do? Now when you get 50 data sets, 50 data points, so you do cross it out like this. It's difficult. So we can think of a way to get the middle value. Now here, how many data points are there? 1, 2, 3, 4, 5, 6, 7. When you get odd number of data sets, data points, you get one middle number. And I'll teach you a short method. So this is 7, 1, 2, 3, 4, 5, 6, 7. So what you do, divide by 2 because we are trying to get the middle. Divide this data set into 2 equal parts. So we'll take divide n by 2. You get 3.5. When you get a decimal number, what you do? Take the next number, 3.5. The next number is fourth one. Fourth one is the midpoint. 1, 2, 3, 4. So straight away we get the mid value. When you get a whole number, what you do? That means you get 2 middle values. We'll take this example and see. 1, 2, 3, 4, 5, 6, 7, 8. 8 is n. Divide by 2, you get 4. Whole number there. When you get whole number means you get 2 middle numbers. What you do? You take the fourth observation, fifth one, divide by 2. Or you can do cross out method. So cross out like this and you will get 2 mid values. So fourth one, 1, 2, 3, fourth one is that, fifth one is that. So how you get the median? You take the average of those two values. So 25 plus 25 divide by 2, that's 50 divided by 2, still you get 25 as a median. Now take the same exercise we did before, number of coconuts sold for 7 days. This is not in order. Arrange this in order. Three 500s are there. And 600 and 700. So what you do? 1, 2, 3, 4, 5, 6, 7. That means one midpoint. 7 divided by 2, you get 3.5. When you get decimal, you take the next observation. Fourth one is the midpoint. 1, 2, 3, 4. So median is 500. So now you know what's the median value. When you arrange the data set in order, the middle value we call median. Now we need to look at mean. Mean, there's another name for mean. Average. Average value is same as the mean value. So how can we find out the mean? We know that mean is total divided by number of terms. So what you do, you add all the terms, divide by number of terms. So when you look at this raw data set about coconuts, number of coconuts sold, what you do, the mean is equal to add all these values divide by 1, 2, 3, 4, 5, 6, 7. 7 days you divide by 7. What's the total? 1000, 1600, 1700, 2000, 2700 plus 500, 3200 divide by 7. 7 times 4, 28. 28 plus 4, so you get 40. 7 times 5, 35. Another 5 remaining for 50. What's the value? For 50, that's 7 times 7, 49. And 1 remaining for 10, that's like 1. So if we can round it to correct to whole number, roughly 457 coconuts sold as the average number. So what's the answer? 457 coconuts as the average number. Now we can make a frequency distribution. So what we do, we take number of matchsticks and we can count how many matchsticks are there using tally mark. Tally. And then when you count all together, the tally marks we call, that's the frequency. We can denote it by letter F. Now we'll see what's the lowest number in the data set. 47. So we can start from 47. 48, 49, 50, 51, 52. What's the highest? Highest is 53. Now you don't need to again and again check how many 47s, 48s, 49s. The easiest way is you look at either row wise or column wise and then put a tally mark. So I'm reading row wise from 49. So 49. I can put a tally mark. 50, 47, 50, 53, 51. That's the first row. Now second row, 48, 52, 49, 51, 50 and another 50. Another 50 comes. Here when you mark tally marks, we can cross out the fifth one. So I can cross out like this. That means the whole set is 5 outcomes. 50, 47, 50, 53, 48, 52. Fourth row, 49, 50, 51, 52, 48, 50, 48, 50. And the last row, 49, 51, 53, 47, 49. 47, 49 again, you can cross it out, and 51. And 51 also you can cross it out. Now you can count how many tally marks are there. So that's called the frequency. 1, 2, 3. 1, 2, 3 here. This is 5. 5 plus 3, 8. 5 and 3, 3. So we can check whether your data set is correct by adding all together. And you need to get how many? 1, 2, 3, 4, 5, 6. 6 times 5, 30. 3 plus 3, 6. 6 plus 5, 11. 11 plus 8, 19. 19 plus 5, 24. 24 plus 3, 27. 27 plus 3, 30. So that's correct. So this is the total number. Then what's the next step? Now we want to find out. This is called frequency distribution. A table with frequencies and the x values. So here we can take this one as x. Number of matchsticks I can take as x. Now we need to find out the mean. What's the formula? Total over number of outcomes. So n is the number. Here we say n is total number of f's. In maths, total means this notation, sigma. Sigma notation is sigma f we can write. That's same as n. In this case, that's 30. Sigma f. So I can write instead of n, sigma f as well. How can we find out the total? Now here 47 3 times means 47 plus 47 plus 47. So when you are adding the normal row data set, you have to add like this, 49 plus 50 plus 47 plus 50 like that. But now we created a frequency distribution. How can we use this distribution to find out the mean? In other words, we can say without adding 47 plus 47 plus 47, we can say 47 times 3. So we take multiplication. So x into f or fx, we call fx. We multiply frequency with the x value. Then you get the total for each part. And then when you take column wise total, you get the numerator value. So we'll try to find out that. 47 times 3. Multiply. 141. 48 times 3. 144. 5 times 49. 245. 50 times 8. 400. 51 times 5. You get 255. 52 times 3. 156. 53 times 3. 159. So when you add all together, you can get the total number, total fx number. So what's that? Add it together. When you add it, you get 1500. So we can write sigma fx is the total fx is 1500. So what's the average or mean value? We can write sigma fx over sigma f. 1500. And what is sigma f? That's the n value, total number of outcomes or observations. So you get 30. So when you divide, you get 50. So what's the average number of matchsticks in a box? 50 matchsticks. So now you know how to find out the average. Then if I ask what's the range of this data set, how can we find out the range? Highest value minus the lowest value. Highest value is 53, lowest value is 47. When you subtract, you get the range. So range is 6. And if I ask what's the mode value of this data set? Mode, so range is this, mode, most frequent number. Look at the frequency column. Find out where you get the highest frequency. 8. So related to 8, what's the x value? 50. So the mode value is 50. If I ask what's the median value, what you do? Median value, roughly 30 boxes are there. So what's the middle? 30 divided by 2, 15, and 16th one are the middle numbers. I told you 30 divided by 2, 15. When you get a whole number, 15 plus 16. So you can add and see where you get 15th in the table. 3 plus 3, 6. 6 plus 5, 11. 11, and after that you get 15th one and 16th one. So that means median is also, you get 50. So in a frequency distribution, you need to know how to get the range, mean, median, mode. Now, we discussed this one before. When you take any type of data, we can divide into two parts. Discrete data or continuous data. What are discrete data? We can find out. Now, only certain numbers you can take. Alright, can take only certain values. For example, number of children in a family. Number of children. So this should be a whole number. You can't get 2.5 or 3.25. It's a whole number. 0, 1, 2, 3 like that. And marks, another example. Collar size. In shirt, when you buy shirts, you get collar sizes. So you get 15 and a half, 16, 16 and a half. Certain values are there. So we call collar size also discrete. Another example, number of runs from a cricket match or something. So number of runs cannot be 0.5. So that's also number of runs. That's a whole number. If we can take all possible numbers within a given range, we call those are continuous. Can take all possible values within a given range. Exam marks. So normally we take as continuous because marks can be 0 to 100. So some teachers round it. If you get 51.5 or something, we round it and keep to nearest whole number. So 52. So that means any value in between 0 to 100, we take marks as continuous. So marks. Height of a person, 6 meters, 6.1 or 1.35 meters. So here we can take height as continuous. Weight of something is continuous. So mostly if we can measure values, we say those are continuous. Can measure. These values can measure. So you need to identify when you get a data set whether it's continuous or discrete. So when it is discrete, you can make frequency distributions. If it's continuous, what happens? You have to group the data set. We'll do afterwards. Now we'll take this example. Number of pins in 70 boxes are given below. Is this discrete or continuous? Number of pins. You can't take a decimal value. So this is discrete data set. So which table is suitable? Frequency distribution. Number of boxes means the frequency is given. We'll take this one as F. Number of pins, I can take this as X. So you are asked to find out mean value. Calculate the mean. So how we do mean value? We can use the formula. Mean is equal to sigma fx over sigma f. Total f values that's given as 70 and sigma fx. So what we do, you multiply these two and find out the total. So multiply now. 96 times 4. 384. 97 times 6. 582. 98 times 8. 784. 99 times 9. 891. 100 times 16,600. 9 times this, 900. 9. 8 times 2. 102 times 8. You get 16 and 8. 103 times 6. And 6. 4 times 104. And now calculate the total. What's the total? So what's the total? You get 7,000. So how can we find out the average value? Average value is sigma fx value, that's 7,000, divide by number of boxes. The total values sigma f is 70. So when you divide, you get 100. So average number of pins in a box is 100 pins. Now if I ask what's the range? 104 minus 96. What's that? 8. What's the mode value? Look at this side, the frequency column, and this side. 16 is the highest number. So mode is also 100. And what about median? Median? Look at the total 70. Divide by 2, 35. That means 35th one and 36th one. So roughly when you add these two together, 10, 18, 20, 27. So more than 27. So in this region is 35th one and 36th one. So median is 100 again. So in this data set, mean, median, mode all are equal and it's 100. So roughly we can say, by looking at all these statistics measures, we can say number of pins in a box is roughly 100. Now look at this one. Mathematics marks for 40 students are given below. I told you when you take data set, sometimes we call it those are discrete, sometimes continuous. Maths marks normally continuous data set. So when you get a continuous data set, it's better to group the data into intervals. So when you want to create intervals, you have to find out what's the minimum number and the highest number. So minimum is 0, maximum is 100. So 0 to 10, 100 numbers are there. Then we have to roughly see how many intervals are there and decide your interval. If we say we want roughly 10 intervals, so when you divide by 10, 100, so you take the difference, not 0 to 100, take the difference, 100 minus 0, divide by 10, roughly 10. So the size of the interval is roughly 10. So I can take the intervals as 0 to 10 and I can do 11 to 20 as well. Taking the next number as 11. 21 to 30. 31 to 40. 41 to 50. 51 to 60. 61 to 70. 71 to 80. 81 to 90. 91 to 100. So these are my intervals. Then what can I do? I need to count how many students in between 0 to 10, 11 to 20, 21 to 30, like that. When you are grouping this, so we call these are intervals. So remember, when you take an interval, there are two values. And also look at these intervals. There's a gap in between 10 and 11. And also there's a gap in between 20 and 21. When there's a gap, we call these intervals are limits. So this is the lower limit and this is the upper limit. if I take without gaps, I can create this interval as 0 to 10, starting from 10 to 20, 20 to 30. If there are no gaps, I can say these are boundaries. So without gaps, we call those are class boundaries. There are no gaps. And here there are gaps, we call class limits. Then if it's 0 to 10, 10 to 20 like that, we say this is the lower boundary and this is the upper boundary. We use the two terms, boundary and limits. Now, if you have given limits, how we create it to the boundaries? What we do, we take the average. Look at this one. How can we get rid of this gap? 10 and 11. You add it and divide by 2. So, I can write without 10, I can write 10.5 and here 0.5, 0 to 10.5, 10.5 to 20.5. So like that you can create intervals. But here we'll do all these values with limits. Now we have intervals. How we decide the frequency? Like before, we decide, read the numbers, put the tally mark and count how many numbers are there. We call that's frequency. So let's take first row, 98, 49, 54, 72, 100, 57, 17, 28, 0, 73. That's the first row. Second row, 50, 57, 11, 23, 88, then 79, 66, 37, 43, 69. Then the third row, 44, 52, 75, 84, 93, 8, 19, 26, 33, 38. Then the last row, 57. Here, fifth one we can cross it out. 62, 80, can cross it out. 46, cross it out. 39, 16, 61, 73, 57, 33. Now we'll see how many students in each category interval. This is 2. This is 1, 2, 3, 4, 3, 5, 5, 5, 6, 4, 5, 6, 2, 3. Now, when you add all together, you need to get 40. We'll see whether our table is correct. 3 plus 2, 5, 15, 15 plus 5, 20, 26, 26, 31, 31 plus 3, 34, 38, 40. So total is correct. And then what can you do? We need, now here we get intervals. So we need the class mark. How can we find out the class mark? So we call class mark or mid value. Class mark, or we call it mid value. We can use X for mid value. What's X? We take the average of the class limits or class boundaries. So add and divide by 2. 0 plus 10 divided by 2, you get 5. 11 plus 20 divided by 2, 31. 31 divided by 2, 15.5. So likewise, you can find out the class mark. And then what you do? You take multiplication and create fx as the total number. Find the total here, sigma fx value, sigma f value, and divide, you get the mean value or average number. So using this table, we'll try to find out the average. So 21 plus 30, 51. 51 is 25.5. Here 40 plus 31, 71, 35.5. So here can you see a pattern? You get 45.5, 55.5, 65.5, 75.5, 85, 95.5. Those are the class marks, and then multiply f into x. 5 times 2, 10. 4 times this, multiply 62. So multiply this by 3. 3 times 5, 15, 1 remaining. 3 times 5, 15 plus 1, 16, 1 remaining. 3 times 2, 6 plus 1, 7. Then multiply this by 5. 5 times 5, 25. 2 remaining. 5 times 5, 25 plus 2, 27. 2 remaining. 5 times 3, 15 plus 2, 17. Multiply this by 5. 5 times 5, 25. 2 remaining. 5 times 5, 25 plus 2, 27. 2 remaining. 5 times 4, 20 plus 2, 22. This one by 6. 6 times 5, 30. 3 remaining. 30 plus 3, 33. 30 and again 33. 4 times 5, 20. 2 remaining. 20 plus 2, 22, and 4 times 6, 24, plus 2, 26. 6 times 5, 30, 3 remaining. 6 times 5, 30, 33, 3 remaining. 6 times 7, 42, 45. This one multiplied by 2, 2 times 5, 10. 10 and 1, 11, 2 times 8, 16 plus 1, 17. So 3 times this is 286.5, and then get the total, add all these together. When you add it, you are getting 2059. So 2059 is the total sigma fx. So what's the average? So I can write the average or the mean value. Mean is sigma fx over sigma f. That's 2059 over 40. So roughly what's the value? Divide 2059 divided by 40. 40 times 5, 200. For 59, that's 1. That's 40. So you get 190. So like roughly 51.4. So that's the average mark of these students. So what you need to know when you are given a big data set and if you want to create intervals, make sure that how you get the class mark or mid value, you add and divide by 2 and then calculate the frequency, take the total of fx, total fx divided by the total f is the average value or mean value. Now look at this example. Below table gives marks of 50 students. Find model class, median class and mean. So what are the intervals here? No gaps in between. So boundaries given, class boundaries given. So how you find out the class mark? Class mark I can write as x. Frequency I can take as f. Frequency is given. So class mark we add and divide by 2. 0 plus 10 divided by 2, 5. 10 plus 20, 30. 30 divided by 2. 30 divided by 2. What's the answer? 50. 30 plus 20, 50. 50 divided by 2, 25. So likewise, we see a pattern. 35, 45, 55, 65, 75. Those are the class mark or mid value. So these are mid values. Then we need to multiply and find the fx value. 5 times 2, 10. 15 times 3, 45. 8 times 25 is 200. 35 times 10, 350. 12 times 45, 60. 6 here, 12 times 4, 48 plus 6, 54. So 540. 55 times 8, 440. 65 times 3, 195. 75 times 4, 300. So what's the total fx? Add it together. $2,008 is the total fx value. So what's the mean? So I'm calculating the mean now. Mean is total fx 2080 divided by 50 given. So divide by 5. 41.6 is the mean mark for this data set. And what is model class? Earlier, when the data is given as values without intervals, we can find out the median or mode. But now the intervals are there, so we say those are model class, median class, like that. So how will you find out the model class? Look at the frequency column, one which has the highest frequency, 12. Which interval? 40 to 50. So 40 to 50 we call, that's the model class. Median class, there are 50 students. What's the half of it? 25. Add and see where you get 25th one, roughly. 2 plus 3, 5. 5 plus 8, 13. 13 plus 10, 23. After 23, this interval, you get 25th one and the next one. So, what's the median class? 40 to 50. So, you need to know how to get the, when you get class intervals, how can we find out the median class, modal class and the average? If I ask what's the interval that belongs to median, now median is 41.6. Which class interval belongs 41.6? This one. So that value is in between 40 to 50. So if I ask what's the median class, not median, class interval belongs to mean, I can write class interval for mean. I can say 40 to 50. Now we can see mean, median, mode, everything in 40 to 50 class interval. Now in this example, if I ask you what's the class size of the interval, how can we find out? Class size is the width of the interval. Class size is the width of the interval. Normally, we take the difference between the boundaries, class boundaries. Here, when there are no gaps, the difference between these two values are the class size. 10 minus 0, 10. 20 minus 10, 10. 30 minus 20, 10. So, all these class widths or class sizes are 10. If I give with class limits, for example, 0 to 10, 11 to 20, 21 to 30. How can we find out the class size? You need to add 1 to that. Take the difference, 10 minus 0 and add 1. This size is 11. 20 minus 11 is 9. 9 plus 1, 10. 30 minus 21 is 9. 9 plus 1, 10. So make sure when you get limits, you subtract and add 1 to get the class size. If you have boundaries, just take the difference. Now we'll look at exercise 26.1. The marks obtained by several grade 10 students of a certain school has been grouped and tabulated as follows. Complete the mid-value column. This column, what is the size of each class interval? What is the modal class? So how can you find out the mid-value? Add and divide by 2. 20 plus 11, 31, divide by 2, 15.5. 21 plus 30 divided by 2, you get 25.5. This one, 35.5. 45.5, 55.5, 65.5, 75.5. Add and divide by 2, 81, 85. 85.5 and the last one is 95.5. Those are the mid values. What is the class size? I told you. These are limits. There's a gap in between. So how you find out? Subtract and add 1. So what's the class size here? 20 minus 11 is 9. 9 plus 1, 10. 30 minus 21 is 9. 9 plus 1, 10. Add 1 to that. So all these class widths are 10. So the class size, what is the class size of each class interval? That's 10. What is the modal class? One which has the highest frequency. Look at the frequency column. This one, 10. So refer that number. So what's the modal class? 51 to 60. Question number 2. The data height to the nearest centimeter obtained by measuring the heights of the children in a certain class is given below. Find the midpoint. By using the table, find the number of children in the class whose heights are less than 150. To which class interval do the height of most number of students belong? First, find the mid value. Add and divide by 2. 140 plus 145, you get 285. 285 divided by 2, you get 142.5. So I can write this one as 142.5. Add and divide by 2 these two, you get 147.5. This one 152.5. When you add and divide by 2, you get 157.5. This one 162.5. This one 167.5. Those are the mid values. Then part 2, by using the table, find the number of children in the class whose heights are less than 150. So when you take this one, this is up 150 we take in this interval. So less than 150 means these two rows. So how many children altogether? Less than 150 centimeters. 8 plus 5, that's 13 students are there. To which class interval do the heights of the most number? Most number is the mode value. Look at the frequency column. 15 is the highest frequency. So this interval is the modal class, 150 to 155. Question number 3. A group frequency distribution prepared using the information on the number of students who were present in a certain school during the first term is given below. Find the midpoint. So copy and complete and answer these questions. We'll try to first find the midpoints and then divide by 2. 531 plus 550, you get 1081. Divide by 2, you get 54. 540.5. This one, when you add, what you get? 500. So 1, you get 1121 divided by 2, 560. 560.5. Then can you see the pattern? If this is 40, this is 60. So add 20 to that. 580.5. This one 600. Add 20. 20 to that, you get 600.5. Add 20 to that, you get 620.5. And answer these questions. On how many days were there less than 591 students present? Less than 591. 591 less means these three groups. 21 plus 4 is 25. 25 plus 10, 35. So 35 students are there. On how many days were there? There are more than 570. More than 570 means these three rows. We have to add these three. You get 3, 43. Altogether 43. How many days was the school in session during the given term? Altogether, how many days? You can add the total. So when you add the total, 67 days are there. Question number 4. The information obtained from a test conducted to determine the lifetime of a certain type of light bulb is given below. Copy the table and complete the mid-value column and answer these questions. 100 to 200, add and divide by 2. 300 divided by 2 is 150. 250. Mid-value 350, 450, 550 and 650 are the mid-values. How many bulbs burned out in less than 400 hours? So this is more than 400 hours. So less than means these 3 columns. So you have to add these 3. 25 plus 5 is 30. 30 plus 12, 42. How many bulbs were used to conduct this test? That's the total number of bulbs. Add and see. 100 bulbs are taken for this test. Assume that the number of hours each bulb that was used remained lit was between 100 hours and 700 hours. So that's the data set given. Example number 1. The following group frequency distribution gives the marks that 40 students received out of 25 on a mathematics test. Class interval and frequency given. Calculate the mean mark. So here same thing I have written other way around. You can't do this way. So it's better to create the table this way. Now what's the next step to find out the mean? So we know this is interval, this is F. We need to find out the X. X means mid value. How can we find out the mid value? Add the two intervals values and divide by 2. So what are these given values? Boundaries given. 8 plus 4, 12, 12 divided by 2, 6. 20 divided by 2, 10. This one, 28 divided by 2, 14. So here just like adding 4. This should be 18. This should be 22. And we need Fx to find out the mean mark. Multiply 6 times 3, 18. 10 times 7, 70. 15 times 4, 14. Multiply. You get 210. 11 times 8, 88. 8 remaining. 11 plus 8, 19. This one 4 times 2, 22. You get 88. So now find the total of Fx. $584. Now calculate the mean value. Mean is equal to sigma Fx over sigma F. So this is sigma F. So what's the value? 584 divided by 40. So 584 divided by 40, long division, you can find out the number. So here roughly 460. So you get 24 4. So for 240, that's 6. So 14.6. And it says calculate the mean mark. So 14.6. This is about mark. So you can roughly round it to the nearest number and write 15 as well. Exercise 26.2. A frequency distribution prepared using the data on the quantity of beans that was brought to a certain vegetable collection center on a certain day by 40 farmers is given below. The information was obtained through a survey conducted on the quantities of vegetables that are brought to the vegetable collection center by farmers. Mass is given and number of farmers. What are these? Boundaries or limits? No gaps in between, so those are class boundaries. Calculate the mean quantity of beans that was brought by farmers. So we need to create the table like this and first find mid value, that's our x value, and then multiply f and x and get the fx value. Total fx divided by total f is the mean value. Now we'll try to find out. Add and divide by 2. 14 plus 18 divided by 2, you get 16. This one, 20, 24, 28, 32. Those are the mid values. Now multiply. 3 times 16. 7 times 20. 15 times 24. We'll multiply here. 360. 11 times 8 is 88. 11 times 2 is 22. 22 plus 8, you get 30. 32 times 4, 120. And what's the total? 984. So what's the mean mark? Here calculate the mean quantity. So mean is equal to 984 divided by 40. Divide and find out the answer. 984 divided by 40, that's 2. 484 roughly. 4. 4 times 0, 4 times 16. You get 24 for 240, that's 6. 24.6 is the mean value. Now, second part, accordingly, what is the quantity of beans that can be expected to be brought to this center during 10-day period? So, this means within 1 day, the mass of beans, that's 24.6 kilograms. For 10 days, what's the mass? So, you need to multiply by 10. So, 246 kilograms of beans brought to the center for during 10-day period. Question number 2. Information on the number of shirts produced each day of a month by a certain garment factory is given in the following frequency distribution. What are these values? These are limits. There's a gap. Calculate the mean number of shirts that is produced per day according to the above information. Based on the mean, find the number of shirts that can be expected to be produced during 3 months. So this is number of days. So first we will try to find out the mean value. We have class intervals and the frequency. So we need to find out the mid value. Add 10, divide by 2. 16 divided by 2, 8. This one, you get 46 divided by 2, 23. This one, 76 divided by 2, 38. This one, 106 divided by 2, 53. And last one, 136 divided by 2, 68. That's the mid value. Then what's the next step? Multiply and get fx values. 8 times 4, 32. 8 times 3, 24. 8 times 2, 16. Plus 2, 18. 6 times 8, 48. 4 remaining. 6 times 3, 18. Plus 4, 22. 8 times 3, 24. 42 here. 4 times 8, 32. 4 times 6, 24. Plus 3, 27. Now take the total. When you add all together, you are getting 1140. So what's the mean value? Mean value is mean number of shirts is total divided by sigma f, total number of shirts. So when you divide, you get 38 number of shirts produced per day. Based on the mean, find the number of shirts that can be expected to be produced during 3 months. This is per day. So how many days for a month? Roughly, if we'll say 30 days, 30 days into 3 months. 3 months, roughly 90 days. So within a day, 38 shirts are produced. So how many shirts altogether for 3 months? 90 times 38, roughly 3,420 shirts. Question number 3. A frequency distribution of the marks received for an assignment by 30 students in a certain class is given below. Class limits are given. What is the size of class interval? Class limits are given. You subtract and add 1. 10 minus 1, 9. 9 plus 1, 10. 20 minus 11, 9. 9 plus 1, 10. 30 minus 21, 9. That's 10, 10, 10. So roughly the size of the interval is 10. What is the model class? One which has the highest frequency. 13 is the highest frequency. So the interval is 21 to 30. Find the mean mark obtained by a student in the class. So you have to arrange the table like this. So what's the first step? Find the class mark or mid mark, mid value. Add and divide by 2. 10 plus 1, 11. Divide by 2, 5.5. 31 divided by 2, 15.5. Here you get 25.5. 35.5, 45.5. That's the mid value. Multiply these two to get fx. 2 times 5.5 is 11. This one, so you need to multiply 13 times 25.5. 10 and 3. 331.5. 4 times 35.5. 2 times this, 91. Now add all together, sigma fx. $750. So what's the mean mark obtained by a student in the class? Total fx, that's 715, divided by total f, that's 30. Divide and say. Long division, 30 times 2, 60. You get 1115. That's roughly 390. You get 25. For 250, you get 8. So 23.8 is the mean mark obtained by a student. Question number 4. The age groups that the teachers serving in a certain educational division belonging to are given in the following table. How many teachers are serving in this educational division? How many teachers? You add everything together, 1132 all together, you get 185 teachers are there. To which age group does the most number of teachers belong? That means the model class. Look at the frequency column, one which has the highest frequency, 31 to 36. Calculate the mean age of a teacher serving in this educational division based on the given information. So mean mark. What's the first step? Find the mid value. So find the mid value, add 10, divide by 2. You get 47, divide by 2, 23.5. Here you get 57, divide by 2, you get 28.5. So what's the next one? 33.5, 38.5. Here 43.5, 48.5, 53.5. Those are the mid values. Now multiply by fx. Multiply 11 times 5, 55, 33, 38. 3, 11 times 2, 22, 25. Multiply by 32. So here you have to do long division and see 32. 30 and 2. So I'm not showing the multiplication. You do separately and add it. So answer is 912. 51 times 33.5. 1708.5. multiply by 40. Put a 0 and then multiply by 4. Thousand 540. Multiply by 27. 43.5, 27, 20 and 7. 1174.5. 18 times, so I'll erase all these. 18 times 48.5. 10 and 8. 873 is the answer. Then this one 6 I can multiply without so here 30 321. Now we have to calculate the total. So what's the total? So when you add these all together, you get 6787.5. So what's the mean value? Mean age. Total effects 6787.5 divided by 185. So we'll do long division and find out the mean value. 6787.5 divided by 185. Roughly, this is like 3. 3 times 5, 15, 1 remaining, 3 times 8, 24, 25, 2 remaining, 3 times 1, 3, 5. So you get 123, take 7, 3 times, so here roughly 6, 6 times 5, 30, 3 remaining, 6 times 8, 48, 49, 50, 51, 5 remaining, 6 times 1, 6, 6 plus 5, 11. Then when you subtract, you get 127 with this 5. Again, you get 6. 6 times 5, this is 1110. You get 165. Again, when you multiply by this, you get 7 roughly. So, mean correct to 1 decimal place, this is 36.7 roughly, because when you take 1 decimal place. So, mean age of teachers is roughly 36.7. Question number 5. The information obtained by measuring the circumference of the tree trunks stacked in a certain lorry is given below. Now the boundary is given, class boundary is given because there are no gaps. Find the model class. How can we find out the model? Look at this one, frequency 1, which has the highest one, 20. So 75 to 100. Using the above information, calculate the mean circumference of a tree trunk that was stacked in the lorry. So you have to calculate the average. So what's the first step? Mid value, calculate, add and divide by 2. 25 divided by 2, you get 12.5. 25 here, when you 75 divided by 2, you get 37.5. Then the next one, you get 62.5. This one, 87.5. This one, 112.5. Those are the mid values. So how you find out fx? Multiply these two columns. 8 times 5, 40, 4 remaining, 8 times 2, 16 plus 4, 20, 2 remaining, 8 times 1, 8, plus 2, 10. This one, just multiply by 10 means you move 1 decimal place. This one, we can do this, 10 and 2, no? When you multiply by 10, 625, multiply by 2, you get 125. When you add it together, 750. This one, move 1 decimal place and multiply by 2. 1750. Multiply by 18. So how you find out? 112.5 multiplied by 10, you get 1125. Multiply by 8, so add it together, you get 2025. Then add total fx. When you add total fx, you are getting 5,000. So the total is 5,000 and total f is 68. So what's the mean circumference? You can find using this formula, total fx divided by total f. Roughly, what's the value? Now find using long division. So this is 7. 47 here. So subtract, you get 10, 1 remaining, 8, 9, 10. So 24. So 240, roughly 3. So 36 for 306, that's 73 point. This should be 4. 5. 5 times 8, 40. 4 remaining. 5 times 6, 30, 34. So 73.5. So what's the circumference in centimeters? So you can write this is centimeters. Now we'll discuss how we can calculate deviation. Now so far we did finding mean using the formula sigma fx over sigma f. Sometimes the calculations are hard because you have to multiply really big number. So we are trying to find out an easy way to find out the mean using deviation method. So first thing, you have to know what is deviation. Deviation is the difference between a value and another value. So for example, if we want to compare this data set with 50, we say this is the value. What's the deviation of other values with this number? So we subtract. So when the deviation is negative, when these numbers lower than the assumed value, and you get deviation positive when the values are bigger than the assumed value. Now if this is 50, calculate the deviations. 20 minus 50 minus 30. 30 minus 50 minus 20. 40 minus 50 minus 10. And 60 minus 10, you get positive now, 10. But here what happens? Here 50 minus 50, you get 0. Now after this you get positive deviation. 70 minus 50, you get 20. 80 minus 50, you get 30. So we can find out the total deviation. So D means deviation. To find out the deviation, you have to assume a value. So this is the assumed value. Then when you add total D is what happens? 30, 20, 10, 30, 20, 10. Here get cancel out. Minus, you get minus 70 and plus 70. So the total deviation is 0. So when you use this method to find out the mean, it's really easy to find out. We'll try to use this method to find out the mean values. We'll take this example. 2016, a data set is given. You are asked to find out the mean. Normal mean is what? Add and divide by numbers. Add all together. 12, 16, 18, 20, 22, 24, 28. $140. Divide by 1, 2, 3, 4, 5, 6, 7. 140 divided by 7. You get 20. So the mean value is 20. But if we take assumed mean as the highest number, like we'll take the middle value something 20. If assumed mean is 20, total deviation, with that we'll calculate the deviations for each value with 20. This is 0. 20 and 18, you get minus 2. Minus 4 minus 20 and 12 minus 8. This side 22 and 20 plus 2 plus 4 and plus 8. So what's the total deviation? When you add all together, you get 8 get cancel out, 4 get cancel out, 2 get cancel out. The total deviation is 0. So how we find out the mean? Actual mean is the assumed mean. Assumed mean plus the total. So we call it mean deviation actually. So not total deviation, mean deviation. Here deviation is 0. 0 divided by 7 is also 0. So you can find out the actual mean value using this formula as well. Assumed mean plus mean deviation. So how we find out the mean deviation? You have to create a value called D and take sigma FD. over sigma f. That's the mean deviation. FD means frequency into D value. Then the calculations are easier than before. Now we'll try to use this formula to find out the mean. We'll take this example. You have given this table and you have to first take assumed mean. So sometimes we take the mode value as the assumed mean, one which has the highest frequency, or you can take any middle value. So I'll take somewhere around 20. This is the assumed value. And now you have to create D. D is the deviation. So how can we create D? You have to compare with this number. 20 and 7. What's the deviation? You get minus 30. 20 with 10, minus 10. 20 with 12, minus 8. 20 with 5, minus 5. Here you get 0. Now compare the higher values. 25 minus 20 plus 5. 28, 20 plus 8 plus 10 plus 13. Now what happens? All these get cancelled out and you get deviation 0. So here total deviation is 0. So how can we find out the mean deviation? Mean deviation is total sigma D is 0. 0 divided by frequency is 0. So what's the actual mean? Actual mean is assumed mean 20 plus 0, you get 20. If we take another number, I want to show with another number. Now we'll take 15 as the assumed one, assumed mean. If we take 15, what's the difference? Deviation. With 15, you get here minus 15 and 7, minus 8. 15 and 10, minus 5. 15 and 2, 12, minus 3. Here you get 0 and this side you get 5. Here 5. 15 and 25, you get 10. 28 and 15, 13. And 15 here. And this one, 33 and 15, you get 18. Now, it's not, the total deviation is not 0. Then you have to calculate the mean deviation. So what's the mean deviation? How can we find out mean deviation? Mean deviation now becomes sigma FD over sigma F. You need to find out the multiplication between these two. F into D. Minus 8 times 2, minus 16. 3 times 5, minus 15. 2 times 3, minus 6. 0 times this is 0. 5 times 2, 10. 10 times 1, 10. 13 times 2, 26. 15 times 3, 45. 18 times 2, 36. Now, when you take sigma FD, add all together, what is total deviation? Sigma FD, add it together. When you add positive numbers, you get 127. When you add negative numbers, what you get? Minus 37. So add it together, 127 minus 37, you get 90. So the total FD is 90. So how you find mean deviation? Mean deviation is sigma FD, that's 90 divided by sigma F, 18. So when you multiply this by 18, so what's the value? 5. So you get mean deviation is 5. So how you get the actual mean? Actual mean is assumed mean. Assumed mean we took 15 plus the mean deviation. You are getting the same answer, 20. But which way is easy? If you take 20 as the assumed mean, only few calculations are there. So when you are calculating the mean using deviation method, make sure that you take the correct assumed mean, because then the calculations are easier compared to now. When you compare these two, you get the same answers, but we have to multiply and get the total and find the mean deviation. So it's difficult than the previous one. Now we'll take this question. Take 51 as the assumed mean, find out actual mean. So they have given, okay, take 51 and find out the actual mean. So that's, this one is the assumed mean. So actual mean is what? Assumed mean plus mean deviation. Now we have taken 51 as the assumed mean. Now we'll try to find out the deviation. 51 and 47, you get 4. So minus 4. I'll put here 51 and 48, minus 3. Minus 50 and 49, minus 2, minus 1, this is 0. And this is plus 1, plus 2. And then it is not 0. When you find out the total, you are not getting 0. So that means you have to find out FD. Multiply 3 times minus 4, minus 12, minus 9, minus 10, minus 8. 0, you get 3, 6. Add it together, this is plus 9 is there, and negative values when you add, you are getting 39. 9 minus 39, you get minus 30. So what's the mean deviation? Minus 30 divided by frequency 30. So you get 1. So 51 minus 1, your assumed mean, the actual mean is 50 in this case. In this example, so if we take 51 as the assumed mean, so this is how you find out the actual mean. Now we'll take another example. You have given a data set and frequencies. You are asked to calculate the mean. We'll use deviation method. So which one we will take as the assumed mean? You have to first take the class mark. These are intervals. How you find out the class mark? Add and divide by 2. So you get 5, 15, 25, 35, 45, 55, 65, 75 are the mid values. Now if we take D as the deviation, and normally we take the mode value as the assumed mean. We'll try mode value and see. What's the mode value? 12. Highest frequency is 12. So related to that, 45 is the mode value. We'll take 45 as the assumed mean. So assumed mean we'll take as 45. What's the difference? Now 45 and 5 you get minus 40. 45 and 15 you get minus 30. Minus 20 here. Minus 20. Minus 10 and here 0. Then this one is plus 10 plus 20 plus 30. When you add it together, these two get cancelled out, these two, but here not getting 0. That means you have to find out FD. 2 times minus 40 minus 80. 3 times minus 30 minus 90. 8 times 20 minus 160. 10 times 10, 100. That's minus. This is 0. 8 times 10, 80. 3 times 20, 60. 30 times 4, 120. Those are the values, and when you add it together, positive values together, 260. Negative values together, 430. 430 and 260, what's the value? 170. Minus 170 is the total FD. So what is mean deviation? Mean deviation is 170 minus divide by 50. So you get roughly minus 17 over 5. So what's the actual mean? Actual mean is assumed means 45 and plus the mean deviation. So what is 17 over 5 roughly? 3.4. So I'll take 3.4 here. 45 minus 3.4. You get 6 here. 41.6 is the actual mean. So this is the question we did before. So we got the same answer without using the deviation method, normal method, sigma fx over sigma f. Now we did using deviation method and we got the same answer. But here can you see the calculations are easier than the previous method. Now we'll take the same question with a different assumed mean, 50. First we'll calculate the class mark. Add and divide by 2, you get 5, 15, 25, 35, 45, 55, 65 and 75. Now the assumed mean is 50. Here 50 is not in the table. Doesn't matter. We'll try to calculate with 50. So assumed mean $50 now. Now take the difference. D 50 and 5 45. 50 and 15 35. This one 25. 15, 10, 45 and 55. This is 5 and 0. And now positive values 55 and 55, 10, 50, 75 and 50. You get 25. This is 65 and 50, 15. So this is wrong. So this is 50. Now you are not getting 0, so you have to find out the multiplication. FD, multiply and see. 2 times 45 minus 90. 35 times 3, 105. 25 times 8, 200. 15 times this, 150. 12 times 5, 60. So all these negative. Now the positive values. Here you are not getting 0. 55 and 50. Positive 5. 65 and 50. 15 and 25. Now we'll multiply. 2 times 45, negative 90. 3 times 35, 105. 8 times 25, 200. That's negative. This is also negative 150. This is minus 60. Now the positive values. 8 times 5, 40. 45 and 100. Now add the positive numbers, you get 185. Negative numbers, 5, negative 605. So here we'll do the calculation. So this is FD. So sigma FD is 605 minus 185. So you get 420, but that's negative 420. So what's the mean deviation? Mean deviation is minus 420 divided by 50. So what's the answer? 5 times 8, 40. For 20, that's 4. Minus 8.4. So what's the actual mean? Actual mean is assumed mean 50 plus the mean deviation. That's 8.4. You get 41.6. So you get the same answer when you take different assumed mean. A value not in the table also works for this method. We'll take example 1. The following table contains data on the number of units of water that was consumed during a month by 70 families. So total is given 70. Who receive water from a certain water scheme. Calculate the mean number of water units that was consumed by family to the nearest whole number. Now we'll try the assumed deviation method to find out the mean. What's the first step? You take the class mark or mid value. That's your x value. 12 plus 14 divided by 2, you get 13. 15 plus 7 divided by 2, 16. 18 plus 20 divided by 2, 19. 22, 25, 28. Those are the class marks. And then you have to take assumed mean. Now here we'll take the highest frequency one as the assumed mean. So 26 is the mode value, and here the x value represent, that is 22. I'll take 22 as the assumed mean. Then what's the deviation? So I took assumed mean as 22. Then what's the deviation? 22 and 13, what's the difference? 22 and 13. 9. So this is minus 9. Here 16 and this, what's the difference? Minus 6. 22 and 16, minus 6. This one, minus 3, and this one 0. This one becomes plus 3 plus 6. Now multiply f and d. F and d, this and this. 5 times minus 9, minus 45. 9 times 6, 54, that's minus. 11 times 3, 33, that's also minus. You get 0 here. Now the positive values. 11 times 3, 33. And 8 times 6, 48. Now add it together. When you are adding here, can we see 33, 33 get cancelled out, and we can add the other numbers. This is 48 and this is minus these two, 99. 99 and 48. What's the difference? Minus 51. So what's the mean deviation? Mean deviation is sigma FD over sigma F minus 51 over 70. What's the value? 51 over 70, 0. For 510, this is like 7, 49. So you get 20. For 200, that's 2. So 0.72. So what's the actual mean? Actual mean is assumed mean minus, here this is minus this value. Because this is minus, because sigma FD is a negative value. What's the value when you subtract? 21.28. Correct to nearest whole number. That's 21. So what's the calculate number of water units? Roughly 21 units to the nearest number. Exercise 26.3. Information on the ages of 100 viewers of a certain television program is given in the following table. What is the model class of the above frequency distribution? One which has the highest frequency. So that's 35 to 45. Find the number of viewers whose ages are less than 25 years as a percentage of the total number of viewers. Less than 25 years. So this is 25 above. Less than means 16 and 7. So what's the number? 23 out of altogether 100 viewers. And as a percentage, and it says as a percentage, that means this is 23 out of 100 means 23%. Find the mean age of a viewer of this program to the nearest whole number. So mean number by taking the mid value of the class interval 35 to 45 as the assumed mean. So this number we have to take as the assumed mean. What is the first step? You have to calculate the mid value. So mid value is add and divide by 2. So what's the mid value here? 10, 20, 30, this is 40, 50, 60, 70. Those are the mid values. Now it says take 35 to 45. This is as the assumed mean. Now calculate the deviation. What happens? When you calculate deviation with this, you get minus 30, minus 20, minus 10. And here you get 0, positive 10, 20, 30. Now FD. This with this. 7 times 30 minus 210. 16 times 2, 32. And put a 0. That's minus. 25 times 10, 250 minus. Then this is 0. Now the positive values. 14 times 10, 140, 5 times 20, 100, 2 times 30, 60. Now add the positive numbers separately and negative numbers separately. You get 300. Negative numbers 0, 8, 7. So negative 780 and positive 300. So 780 and 300. 480, that's negative. So what's the mean deviation? Mean deviation is minus 480 divided by total number. That's 100. So that means minus 4.8. Then assumed mean is 40. So what's the actual mean? Actual mean is assumed mean plus sigma FD over sigma F. That's minus 4.8. We get 35.2 as the actual mean value. So what's the answer for this one? Find the mean age. So mean age is correct to the nearest whole number. So 35 years. Question number 2. The following table has been prepared using the number of days of leave that the staff of a private organization took during a year. What is the model class? Look at carefully and find out the highest frequency. 20. So what's the model class? 12 to 18. If gifts are to be given to those who took less than 6 days leave, what percentage of the total staff will receive gifts? Less than 6 days. This is 6 or more. So 5 people out of the total number. When you add all together, you are getting 70. And you are asked to give as a percentage. That means you multiply by 100. As a percentage, you can get, so 5 over 70 multiplied by 100. 0, 0. 50 divided by 7. So it's keep on going. So roughly 7.14%. So roughly 7.14%. This is about number of people. So roughly 7%. So you can't say 7.14 people. So roughly you can write 7%. 7 staff members out of 100 get the gift. Find the mean number of days of leave taken by a staff member of this organization by using the mid value of the class interval as 18 to 24, this interval, as the assumed mean. Okay, so we'll calculate the mid values first. How you calculate the mid value? Add and divide by 2. You get 3. Here, what's the value? 18 divided by 2, 9. This one, 30 divided by 2, 15. 20. Here, 22. This is 22, 24, 18 when you add. 42 divided by 2, 21. Here 24 and 30, you get 27, 66, 33, and this one you get 78 means divide by 2, 39. Those are the mid values. So here how we find out the assumed mean? They mentioned to take 18 to 25 interval. 18 to 25 is this. So assumed mean we have to take as 21. Now we'll calculate the deviation. Take the difference, 21 and 3 minus 18. 21 and 9, you get minus 12. 21 and 15, we get minus 6. And here 0. And then this way you get plus 6, plus 12 and plus 18. Now calculate FD. This and this, okay, don't multiply these two. FD means this and this. 5 times 8, 40, 4 remaining, 5 times 1, 5 plus 4, 90. So minus 90. 15 times 12, 12 times 5, 60, 6 remaining, 12 times 1 is 12, plus 6, 18, 180. 20 times 6, 120. You get 0 here. Now the positive values. 8 times 6, 48. 12 times 6, 72. 5 times 18, 90. And now add the positive values separately. 210. Negative values, you get minus 390. Now take the difference. 390 and 210 minus 180. Now calculate the mean deviation. Mean deviation is minus 180 divided by the total number 70. So you get minus 2, 14 for 40, 7 times 5. 35 again for 50, that's 7. Roughly minus 2.57. Now what's the actual mean? Actual mean is assumed mean 21, add the mean deviation. This is negative, so we subtract. $18.43, and they ask this is correct too. No, not the whole number. Now this is roughly 18.43, we can take as 19. So what this means? Actual mean means number of leave days per one staff member. So there are 70 staff members. So what's according to the fourth one? According to the answer 3 above, how many man days of work can organization expect to lose during a year? Altogether 70 people are there. So 19 times 70 man days expect to lose. So 0, 7 times 9, 63, 6 remaining, 7 times 1, 7, 7 plus 6, 3, 130, 1330 days expect to lose for the organization. Question number 3. A distribution of the marks obtained by 240 students at an examination is given below. To which class interval does the greatest number of students belong? Mode value. So, 48 is the mode value, highest frequency. So, interval is 36 to 44. By taking the mean value of the model class as the assumed mean, find the mean mark of a student. So, we have to take this one as the assumed mean value. Before that, we have to calculate the mid value. How you calculate? Add and divide by 2. So, you get 4, 13, 22. So, what's the midpoint here? 31. This one? 40. Here, can we see a pattern? Adding 9. So, this should be 49, 58, 67, 76. Those are the mid values. Now, they are asking us to take the assumed mean as the model class value. Model class value is this one. So, that's the assumed mean. So, we'll calculate the deviation now. Deviation is difference between these two, 40 and 4 minus 36. 40 and 13, what's the difference? 27. 22 and this minus 18, and here minus 9, this becomes 0. Now this way difference. You get positive 9, positive 18, positive 27 and positive 36. Now calculate the FD value. Multiply F and D. 36 times 15. You get 540. That's negative. 18 times 27. $486. That's negative. 18 times 39. $702. 9 times 39. 351. 48 times this is 0. Now positive values. 297. 23 times 18. You get 414. 27 times 14, we'll take the space now. 27 times 14. you get 378. 27. Now we have 36 times 11. So multiply 11 times 36. You get 396. Now add positive values separately. You get 1485, and negative numbers separately. You get 9 here, and so when you add negative numbers, you get 2079. Now take the difference. 2079,485. What's the difference? 594. That's negative. 594. Now calculate the mean deviation. So mean deviation is sigma ft, that's minus 594 divided by total 240. So what's the value? 594 divided by 240. This is 2, and the remainder is 114. For 1140, this is like roughly 4. So roughly minus 2.4. That's negative. Now actual mean. Actual mean is assumed mean plus the mean deviation. So actual mean assumed mean is 40 minus 2.4. So 37.6 is the actual mean. So that's the mean mark of a student. Third part, if the 30% of who have obtained the lowest marks are to be given remedial lessons, determine the mark below which a student would be selected to follow this lesson. So altogether 240 students. So 30% of that, what's the value? You get 72 students. So we have to see where you get 72 students. 15 plus 18, 33. 33 plus 39, 72. Now up to this point you get 72 students. So that means what's the mark below 27? So below 27 means 26 or less than that. So what's the lowest mark? 26 is the lowest mark a student can take. If the top 20% are to be awarded distinctions, above which mark should this selection be made? 20% of 240. So you need 48 students. So this way 48 students. So calculate 14 plus 11, you get 25. 25 plus 23, you get 48. So up to this position, you get 48 students. So what's the lowest mark? So above 54, they need to score. So what's the mark award for distinction, 54 above. Question number 4. A table with information on the amount of rice that was sold during a period of 90 days at a cooperative store is given below. Write down the model class, one which has the highest frequency, that's 21, 251 to 275. By taking the mid value of the model class as the assumed mean, calculate the nearest kilogram, the mean amount of rice sold in a day during this period. So, we have to find out the mean value. So, what's the first step? We have to find out the mid value. Now, find out the mid values. So, what's the addition? 151 plus 175 divided by 2, you get 163. What about this one? What's the value? Add and divide by 2, 188. 201 plus 225 divided by 2, 230. This one, add and divide by 2, 238. This one, 251 divided by, add 275 divided by 2, 288. This one cannot be 288 here. That's more than that. What's the number? 263. This one, 276 and 300 in between, 288. This one, what's the difference? You get, add and divide by 2, 313. And the other one, 338. Last one, you get 363. Those are the mid values. Now it says take the mean. Take the mid value of the model class. Which one is the model class? 251 to 275. This one. So you have to take this one as the assumed mean. Now take the difference. When you subtract this and this, what you get? Minus 100. This and this, minus 75. And what about the other difference? 263 and 213, you get minus 50. This one you get minus 25. Here 0. Other way around, you get 25, 50, 75 and positive 100. Now multiply F and D. 100 times 5 minus 500. 75 times 7 minus 75 times 7 minus 525. What about the other one? 50 times 7, 350. 10 times 25 minus 250. You get this one, 0. 16 times 25, you get positive 400. 50 times 10, 500. 75 times 8. What's 75 times 8? You get 600. And here you get 100 into 6, 600. Now add the positive values. You get 2100. So when you add negative numbers, you get 1625. What's the difference? 2100, 1625. $475. That's positive. So this is 475. Now we'll calculate the mean value. Mean is equal to, assumed mean is 263 plus 475 divided by 90. So roughly, what's the value? 475 divided by 90. You get 5. 45 for 250 roughly, you get 280, and you need the nearest amount or not nearest kilogram. So 1 decimal place is enough for that. So 5.2. So 263 plus 5.2, when you add it together, you get 268.2 to the nearest kilo, 268 kilograms. That's the mean value, mean amount of rice sold in a day. Third part, if this pattern of sales is expected to continue during the next 2 months, to estimate the amount of rice that should be stored to be sufficient for the next 60 days. So this is for 1 day, and they need for 60 days means for 2 months. So you have to multiply by 60. So the third part is 268 multiplied by 60. That's the answer. So what's the answer? Multiply by 6. 16,080 kilos, sufficient for the next 60 days. What is the probability of the amount of rice sold during a day in this period exceeding 300 kilos? Look at the table. Exceeding 300 means this number. 10 plus 8, 18. 18 plus 6, you get 24. So 24 out of 90. So that's the probability. Simplify. When you simplify this, divide by 2, you get 12 over 45. You can divide this by 3 again. So what's the probability? So probability is 4 over 15. Question number 5. Frequency distribution of the marks obtained by 2 groups of 100 students, each for a mathematics test, is given in the following table. What is the maximum mark that a student may have obtained in this test? What's the maximum mark? According to the table, 90 is the maximum mark, because the maximum value here is 90. Find the mean mark of a student in each group by taking the mid value of the class interval 41 to 50 as the assumed mean. So we'll find out. Calculate the mid values. So mid values, 1 plus 10 divided by 2, 5.5. Here, what's the value? 31 divided by 2, 15.5. Here, 25.5, 35.5, 45.5, 55.5, 65.5, 75.5, 85.5. Those are the mid values. Now, we have to take this as the assumed mean. So, what's the deviation? Subtract these ones. So you get minus 40, minus 30, minus 20, minus 10 and 0. This difference 10, 20, 30, 40. Now multiply F and D. You get minus 160. This one minus 240. This one minus 360 minus 240. And you get 0 here. This 140, 200. You get 140 and 200. This one 120 and 80. Now add positive values separately and negative values separately. You get 540. Negative values when you add, negative 1000. 540 and negative 1000. So 1000 minus 540, you get 460, that's negative. Now how can we find out the mean mark? So the mean is equal to assumed mean 45.5 and the mean deviation is negative 460 divided by 100. So this is 45.5 minus 4.6. Subtract. What's the value? You get 40.9 as the mean value. So what it means? That's the mean mark of a student in each group. Then the third part, this is second part. Third one, now 14.9 means this is for mean mark for group A. Mean for group A. Now we have to find out mean for group B. So we'll take the same table and find out mean for group B. So they have asked to take the mid value as 41 to 50. So we'll take the same thing, 41 to 50. So calculate the mid value. And then divide by 2, you get 5.5. Same values you are getting as before, 15.5, 25.5, 35.5, 45.5, 55. We did that before. Now take this one as the assumed mean, calculate the difference. You get, subtract minus 40, minus 30, minus 20, minus 10, 0 and take the positive value 10, 20, 30, 40. Now multiply F and D. 7 times 40, 280. 30 times 9, minus 270. 20 times this, 340. That's minus 260 and you get 0 here. Positive numbers 150, 160, 90 and 40. Add the positive numbers, you get 440. Add the negative values, you get 0. Five, 2, 1150, that's negative. So 1150 and 440, you get 710, that's negative. So what's the mean mark for B? Mean mark for B is assumed mean is 45.5 and this is minus 710 divided by 100. So you get 45.5 minus 7, so divided by 100, 7.1. We get 4 and 8, so 38.4. So mean mark for B is 38.4. Mean mark for A is 40.9. Now the third part asks, thereby determine which group of students performed better at the test. Which mean mark is high? Mean mark of A. So last part, the answer is which group is better? Group A, because the mean mark is higher compared to mean mark of B. Question number 6. A frequency distribution containing information on the number of electricity units used during a certain month by 100 households is given below. What is the model class? Look at the highest number, 34. So 61 to 70 is the model class. Find the mean number of electricity units used by a household during this month by taking the assumed mean to be mid-value of the interval 61 to 70. This one we have to take. Now we'll see how to find out the mean value. Take the mid-value first. Add and divide by 2. So 31 and 40. So 71 divided by 2, 35.5. This one, 91 divided by 2, 45.5. So this is 55.5, 65.5, 75.5, 85.5, 95.5. Then what's the next one? Take the assumed mean as this. Subtract. When you subtract, you get minus 30 is the difference. And then this one and this one, minus 20, minus 10, 0. This is 10, 20, 30. Now multiply F and D. So I'll create the table here. I'll calculate FD here. This way I'll calculate FD. $30 times 5 minus 150. 20 times 12 minus 240. 10 times 26 minus 260. 0 times this 0. 10 times 18, 180. 20 times 3, 60. 30 times 2, 60. Add the positive numbers, you get 300. Calculate the total of negative values, you get 650. So minus 650 plus 300. So answer is 350, that's negative. Now we'll calculate the mean. Mean is assumed mean 65.5 minus 350 divided by 100. So 65.5 divided by 100 means this is 3.5. So subtract, you get 62 as the mean mark. So mean number of electricity units used is 62 units. Now the third part. When the number of electricity units used lies in the interval 61 to 90, the electricity board charges 14 rupees per unit. Accordingly, what is the income that the electricity board can expect to earn from these 100 households during that month? Now, 62 means average units consumed by one person, one household. So it's actually 62 means in between 61 to 90. So they charge 14 rupees per unit. So 62 units are there. One is 14 rupees. So altogether this much they have to pay to the electricity board by one household. There are 100 households. You have to multiply this by 100. So what's the total amount that electricity board receive? You get 62 times 14. You get 868. 868. So what's the total? 868,000 rupees expect to earn from 100 households. Question number 7. Information on the monthly telephone bills of the customers of a certain private telephone company obtained by conducting a survey in a particular region is given below. What is the model class? One which has the highest frequency. So this one, 700 to 850. Find the mean monthly telephone bill of a customer in this region by taking the mid value of the class interval 550 to 700. So we have to find out the mean value. So take the mid value. Now calculate the mid values. 100 plus 250 divided by 2. So what's the value? 175. What's the mid value of 250 and 400? 325. What's the other number? What's the difference between? Not the difference. Add and divide by 2. 475. This one 500. Here 475. What's the other number? Add and divide by 2. You get 625. This one 700 and 850. What's the number? 775. This one, what's the difference? You get, not the difference, add and divide by 2, 925. This one, 1075 is the mid value and the other one is, so this one, add and divide by 2, 1225. Now we have to take the mid value as this and calculate the difference. So what's the difference between these two? 625 and 175. What's the difference? Minus 450. The other one, what's the difference? Minus 300. 625 minus 475 minus 150. Then you get 0 here. 775 minus 625. You get plus 150. Here plus 300 plus 450. And what's the last value? 1225 minus 625. You get 600. So those are the deviations. Now multiply F and D. So 2 times this you get minus 900. 300 times 5 minus 1500. 7 times this 1050. So here you get 0. What's the other value? When you multiply by this, you get 3000. This one again 3000. 450 times 8, you get 3600. And this 1800. Now add separately, add the positive values and the negative values. We'll do that. 11,400, and what's the negative values? Add it together. So here you get 5, and so 5 here, 3,450. Now take the difference. 11,400 and 3,450. $7,950, that's positive. 7,950 as the FT value. Now calculate the mean. So mean, I'm doing the second part. Mean is equal to mid value 625, and then mean deviation is 1000. It says 7,950. So this is plus 7,950 divided by 70. Now divide and see. 625 plus divide by 7, 1, 25, that's 7. 7 times 3, 21, and you get 40. 40 means 7 times 5. So roughly this much. So we'll take correct to one decimal place. So 113.5. So when you add these two, what you get? 738.5 is the mean value. So monthly telephone bill roughly 738.50. So 738 rupees and 50 cents. Third part, according to the above mean, what is the income that the company can expect to earn in a month from 1,000 customers who use this type of telephone service? So this is for one person. If there are 1,000 customers, you can get this value multiplied by 1,000. So you get 7385. So what's the value? 738,500 rupees. Fourth one. So we have to check more than 30% of the customers in this group are entitled to that. So 30% of that, 70 means, what's the answer? You get 21 people. Now calculate and see where you get 21. 8 plus 3 is 11. 11 plus 10 is 21. So that means the boundary value is 850. So that's correct. So 850, if the value is more than 850, 30% of customers entitled for that. Question number 8. The following table contains information on speed of the vehicles that passed a certain location during a period of 2 hours. The interval 30 to 40 denotes the interval of speeds which are greater than 30 but less than or equal to 40. So that this means less than or equal to 40, and 40 includes in the other interval. What is the modal class of this distribution? Look at this one. So 50 to 60 is the model class. If those who exceed the speed limit 70 kilometers are taken to courts, find the percentage of drivers who are taken to courts for exceeding this speed. 70 above. So this is less than 70. So 70 above is 5. 5 drivers. 5 drivers out of altogether 60. Multiplied by 100 because we need the percentage value. So 50 divided by 6 or 25 divided by 3. 25 divided by 3. 3 times 8, 24. For 10, that's 8.3 lakh. So roughly 8%. Then third part, find the mean speed of vehicle which passes this location by taking the mid value of the class interval 50 to 60 as the assumed mean. So for that we have to calculate the mid value. (20 plus 30 divided by 2, 25, 35, 45, 55, 65, 75 and 85. We have to take this is as the assumed mean and calculate the deviation. 55 minus 25, you get 30. That's minus. This is minus 20, minus 10, 0. Then this way you get positive. 20, 30. Now calculate F and D. These two multiply. 5 times 3, 150, that's negative. 7 times this, minus 140, that's negative. 12 times 10, 120, that's negative. This is 0 and positive values here. 150, 60 and 60. When you add it together, positive values when you add 270. Negative values when you add 410. So take the difference 410 and 270. You get 140. So that's negative. So negative 140. Now calculate the mean value. Mean is equal to assumed mean, that's 55 minus 140 divided by 60 because that's the mean deviation. Calculate the value. You get 55 minus, here 14 divided by 6 is same as 7 divided by 3. So what's 7 divided by 3? You get 2.33 like that, 33. So subtract, you get 7.3, 7 plus 3, 10, 1 remaining, 4 and 6, 1 remaining. So 2 and then 5. So 52.67 is the mean value. So this is about speed. So 52.67 kilometers per hour. Fourth part, this is the third part. Then fourth part, what is that distance that can be covered during a period of 2 hours by traveling at the mean speed? So the time is 2 hours. This is about, so per 1 hour, this is 52.67. For 2 hours, you multiply this by 2. So 52.67 multiplied by 2, you get 105.34. So that's the distance in kilometers. So they ask what is that distance that can be covered during a period of 2 hours by traveling at the mean speed. So 105.34 kilometers. In this lesson, we covered how to find out the mean using normal method as well as using the deviation method. So it is important to decide which value to take as the assumed mean.